In this video, we will compute the probability of an event happening at least once. In other words, we'll calculate the complement. So as a reminder, the complement of an event, E, sometimes we denote as E to the power of C or EC. Sometimes you also might see it as E prime. It's the set of the outcomes in the entire sample space that are not in E. So E complement is not E. And to calculate it, we just subtract the probability of E from 1. Let's try an example. A fair-sided coin, or a fair coin, is flipped 4 times. What's the probability that it lands on heads at least once? So we want the probability of at least one head in 4 flips. So that at least once piece is our complement. So in order to calculate the complement, we are going to use this principle, that's the same as 1 minus that kind of opposite probability, that we get no heads in 4 flips. Now the reason that we decide to calculate it this way is because it's a simpler case to calculate no heads than it is to calculate all of these cases where you're saying at least one, because that could be 1, 2, 3, or 4. So we're just making our lives easier basically by using the complement rule. So now let's actually do this. So calculating the probability of no heads in 4 flips. 1, 2, 3, 4. There's our 4 flips. And we want to get a tail, a tail, a tail, a tail, because we want no heads. So what's the probability of a tail? 1/2, 1/2, 1/2, 1/2. Okay, multiply all these together because each flip is independent. And we get 1/16 is the probability that in 4 flips we get no heads. Now we just calculated this piece of our probability. So we need to plug that in and do 1 minus that. 1 minus 1/16, which is equal to 15/16. So this is the probability that we get at least one head in 4 flips. Let's try one more. A 6-sided die is rolled 4 times. Okay, so before we were flipping a coin, now we're rolling a die. What's the probability that a 2 or a 3 is rolled at least once? Okay, the probability of a 2 or 3 at least once in 4 rolls. Okay, instead of calculating all those different cases, I'm going to calculate the complement, which is 1 minus the probability of no 2 or 3 in 4 rolls. Because that's a little bit simpler to calculate. So let's calculate what is the probability that we get no 2 or 3 in 4 rolls. 1, 2, 3, 4. There's our 4 rolls, and we do not want to get a 2 or a 3. That means we could get a 1, a 4, a 5, or a 6. So we have 4 other options out of our 6. And since they're all independent rolls, we can multiply them together. So we could have reduced this fraction down to 2/3, and we're multiplying it by itself 4 times. And when we do that, we get 16/81. So that's the probability that we get no 2 or 3. So that was the complement, but that did not answer our question. So we get 1 minus 16/81, which is 65/81, which is our exact fraction answer. Or if you divided those, we would get about 0.802, or about 80.2%. So I think this percentage just helps us kind of understand that, it helps us interpret. So what's the probability that a 2 or 3 is rolled at least once? 80%. So a pretty big probability.